All right, so we got this one. We are going to reflect this quadrilateral over the line y equals x, and then we're going to dilate that reflection using the point of dilation of -1 comma -5 with a factor of 2. All right, so we're putting a whole bunch of things in here. We're graphing linear equations, we're reflecting an object, and then we are dilating that object. All right, so what is the y-intercept for the equation y equals x?
0.
0, okay, cool. So I'm going to put a dot at 0, comma 0. What is the slope for the equation y equals x? 1. So that's 1 up, 1 over. So we're going to, from 0, comma 0, we're going to go 1 up, 1 over, 1 up, 1 over, 1 up, 1 over. And we are going to continue that all the way across the grid. And so we're going to draw our line of reflection right there. So thumbs up, you're good to move on. Thumbs down, you're not. You need a little more time. Okay, 30 more seconds.
I lost my connections.
Thumbs up. Okay. So the next step is we are going to have to reflect this quadrilateral over the line of reflection. So let me ask you this. How many diagonals is this point from the line of reflection?
1.
1. So right now, if it's one diagonal above the line, the reflection, that point is going to be reflected 1 point below that line, right? So the new point will be at 1 comma -1, won't it? Okay. And just to make life a little bit easier, I'm going to call this point A. And this point right here, this point has a relationship with point A, but it's not point A. So instead of writing just point A, I'm going to call this point A prime. And this little looks like an apostrophe, means prime. That's how we say it, A prime. Just so that we know that has a relationship with point A, but it's not the same as point A. While we're at it, I'm going to call this B, C, and D. I'm using really original names for these points. So how many diagonals is point B from the line of reflection? How many diagonals?
3. 2.5.
I would actually call it 2.5 because here's 1, 2, and then a half. So how many diagonals does it have to be, or how far away from the line of reflection does it have to be?
2.5.
2.5. So here's half, 1.5, 2.5. And what am I going to call this point?
B prime.
B prime. It's almost as fun as Optimus Prime, but not quite. Way. All right, Miss Sauter was pretty excited about the Optimus Prime quip. All right, how far away is point C from the line of reflection? Anybody? Hello?
Yes, I said 2.5.
2.5.
2.5. Yes, 2.5. All right, so we have half, 1.5, 2.5. What am I going to name this point? C prime. All right, and finally, we need to do the same thing for D to find D prime. There's a 1. How many diagonals? You guys at home, how many?
4.
4. So 1, 2, 3, 4. And what am I going to call this point?
D prime.
D prime.
D prime.
Excellent. And so let's go ahead and connect the dots. So I'm going to connect A and B. Then from B to B prime to C prime. From C prime to D prime. And then back to A prime. And it should look like a mirror image along the line y equals x. But are we done yet? No, that would be way, way too easy, wouldn't it? I know, dang it. All right, so I know the problem with 8th grade is not only do you have 2-step problems, but now you have to deal with more than 2-step problems. So I'm going to turn this into this image right here. So I'm going to erase the work that I've used so far so it makes it a little bit easier to see. Is everyone okay with that? All right, so go ahead and erase that. All right. Now I lost my points, so I'm going to relabel the points because I need to know what these points are called. So here's A, B, C, D, A prime, B prime, C prime, and D prime. All right, so now we need to do our dilation. Super fun dilation now. So what point are we using to dilate this figure?
-1, -5.
-1, -5. So I'm going to go -1, -5. So 1 to the left, 5 down. 1, 2, 3, 4, 5. And I'm going to put a little dot there. So this is our point of dilation. And it's always easier when you're doing a dilation to create some construction lines that we're going to go from the point of dilation, and I'm going to connect that point of dilation with each vertex of my figure. So in this case, from the point of dilation to A, and then I'm going to continue it all the way across the grid because it makes me happy, and it makes this much easier later. And then, oops, of course I'm using the wrong tool. So then I'm going to connect the point of dilation with point B and extend all the way through. So is anyone confused on what I mean by connecting the point of dilation with the vertices? Okay. From point of dilation through point D prime, point of dilation through point C prime. And so I have this little figure. Okay, thumbs up, I can move on. Thumbs down, I cannot.
Hold on a second.
No worries. I would say we're moving pretty fast. Thumbs up? Okay, all right. So let's look at the point of dilation in point A. And I'm going to make kind of a slope triangle. How far up and how far over did I go? This is not a trick question. 1, 2, how far up?
4 up, 2 over.
4 up and 2 over. All right. Now for this dilation, I have a dilation factor of 2. So I'm going to multiply the vertical distance and the horizontal distance by 2. So instead of going up by 4, I'm going to go up by 8. Instead of going over by 2, I'm going to go over by 4. Okay, so let's go up 4. So up 8 rather, over 4. Oh, look. I find a point that's directly on my construction line. That's a nice little way to make sure I'm doing it right. Cool. All right. Let's look at B prime. How far over, how far up? Okay, 2 over, 1 up. So now how far will I go for a point, for my new point?
4 over, 2 up.
4 over, 2 up. Oh, look, it's directly on my construction line. That's so cool. Whoa. Do you think that's going to happen for all of them? Yeah, okay. It makes it a lot easier. How far away from the point of dilation is point D? And this is a horizontal line. 5. So now how far will it be? 10. So that's 1, 2, 3. Yeah, it's not 5 over. It's how many? It's 4 over. 4 times 2 is 8.
8.
And finally, you go ahead and find the corresponding point to C. And then connect the dots. Whoa, look at that. That's huge. Doesn't it kind of look like that figure is exploding out of that point of dilation? It's pretty cool stuff. Last thing about naming. So if we called this point A prime, what's cooler than a single prime? A double prime. A double prime. All right, so we're going to call this A double prime. What are we going to call this point right here? B double prime. How about this point way down here? C double prime. How about this last point right here? This is
D double prime.
D double prime. So now, congratulations, pat yourself on the back. Not only did you graph the line y equals x, but you also reflected a figure over the line y equals x, and then you dilated it using a factor of 2 from the point -1 comma -5. There you go.
I think Molly's sitting on the bathroom floor.
Is everything okay there, Molly?
She's talking about her.
Oh, I'm sorry, I didn't mean to bother you. All right. I don't know how to feel about that. All right. So, all right. Now, transformations are going to show up on your interim on Thursday. So just really quickly double check. When we did a reflection, did we get a congruent figure? Yes, so a reflection gave us a congruent figure. If we rotate a figure, will it get us a congruent figure? Okay, so translations and rotations, congruent figures. How about reflections? Reflections, congruent. How about a dilation? Does a dilation give us...
I got a thumbs down on the reflection.
Really? I could swear that this reflection looks a lot like this reflection. Like same size, same shape, huh?
Yeah, I guess so.
Yeah, okay. Does a dilation give us a congruent figure?
Oh, that's the thumbs down.
No, that's the thumbs down. Because it's similar, but it's bigger. Much bigger. All right, are there any last questions on this piece of homework that I know it gave you guys some troubles over the weekend? Okay.